Hey everybody, Gary Simmons here for the Game Institute with a really exciting Dead Earth project release for you. I'm basically releasing the preview project that has all of the systems implemented in it that we're going to be creating in the upcoming videos. Now, for those of you that are right up to date with my videos, you will recall in the last video that I said that when we move into part 3 of Dead Earth development, which was basically the development of the arms and weapon systems, I said that although I was still going to cover the development of those systems step by step in the videos, just as I have always done, I said that I was also going to make available to you my experimental project right from the get-go, so you can start to poke around, for those of you that are inquisitive, to see the systems that we're going to build. Now, this project has a lot more in it than just the arms and weapon system. It also has a procedural IK system for making our zombies ascend and descend stairs in a much more elegant manner than would be the case if we simply left it to the navigation system to deal with. We also have the AI door system, so our zombies will be able to go up to doors, and if the door is openable by zombies, then it will go up and we'll use IK to make the hand grab the handle and rattle the handle a little bit before the door opens. And we're also going to support doors that can't be opened by zombies, and instead of just being ignored by zombies, zombies will still go up to these doors and try to open them. So you can imagine that's going to be pretty tense in the game. If you hear a zombie on the other side of the door walking up to that door and then start to rattle the handle, you're not going to know whether that zombie is going to be able to come into that door or not. And we're going to have control over which doors zombies can open on a per door basis. The AI has also had a lot of additions to it on top of the door system and the procedural IK step system. A few bug fixes as well, which didn't really come to light until I started putting the zombies in the hospital and seeing how they worked with multi-story geometry, so they've all been fixed. And you'll notice this project is actually called Dead Earth 2018.3 Experimental, because that's what this is, my experimental project. Now, for the most part, this project will end up being almost identical to the project that we create in the videos. But I think I've mentioned in the videos in the past that before I record my lesson videos, what I have is an experimental project that I use to develop all of those systems and just check that everything works before I then build it all again in the actual project that you see in the lessons. So for the most part, the project that you see now is probably going to be identical to the final project that I'm going to create in the videos. And if there are any differences, it might just be, I don't know, like a folder is called a different name or something like that. You'll also notice whenever you launch this project that you'll get this welcome message coming up, which tells you about all of the new things that are in this project. Now, this is not only going to pop up whenever you launch the project, which might be annoying, but it also will pop up sometimes when you just recompile a script. So once you've read that and you're sick of seeing it and you don't want to see it anymore, you can get rid of it by simply going to the project view, drilling down into the Dead Earth folder and into the editor folder, and you'll notice there's a editor script in there called welcome message.cs. Just delete that and that will stop that welcome message coming up. So without further ado, let's take a little tour of the weapon system. Now, when you start off in Dead Earth, you don't actually have any weapons. What you do have is a flashlight, and well, you do have one weapon, right? You have your fists. So you can see that the fists have now been modeled. We have a few different types of fist punches. And in Dead Earth, the arms animator controller very much works with a left side and a right side separately. So you can see, for example, that when I raise my torch, my flashlight, you can see that I can still fight with my fists, but now it's only going to use the right fist because that's the only one that is available. Basically, you can imagine that there's a curve on the flashlight animations which tell the rest of the animation state machine that the left hand is occupied, and therefore if we want to pick up a two-handed weapon, the flashlight must be lowered first. So you can see the flashlight is greatly improved. Not only do we have a hand and an actual flashlight mesh now, but we also are using a flashlight cookie on the light, so we get to see like that flashlight lens projected onto the wall. And you can see that as we move as well, we can see the flashlight bobbing up and down, and when we run, that's much more pronounced. We can raise and lower the flashlight just as we turned it on and off before, using the flashlight toggle key, which is F by default. And when we pick up single-handed weapons such as our pistol, pick up that ammo as well, you can see that we're still allowed to have our flashlight, and our flashlight still works independently. And likewise, we can raise and lower the pistol if we want, independent of the flashlight. Now, you'll also notice that as we select each weapon is allowed to have its own type of crosshair. So if I lower the weapon and just come up with the fists, you can see the crosshair in the center of the screen is this very understated small crosshair. But if I raise my single-handed weapon, which is the 1 key, you'll notice that will bring up my pistol, and then the crosshair changes to the pistol's crosshair. And the crosshairs are actually really cool because not only do they bob around when you're moving around, so if you're running and trying to shoot things, it can be quite hard, but when you're doing things such as reloading, the the crosshair elegantly fades out so that we don't see a crosshair kind of bobbing all over the screen as your gun's being thrown around in front of you. That's true when you raise and lower it as well. You'll see as I lower the pistol, the crosshair will sort of elegantly fade out or elegantly fade back in again as I bring it up. Every weapon in Dead Earth, apart from melee weapons, also have a dual mode. So in its standard mode, we're holding kind of the weapon and we're firing from the hip, so to speak, like so, right? And we can run and fire when we do that. But if we want more accuracy, we can click the right mouse button by default, and we'll kind of go into almost like a zoom mode where we get to only walk very slowly. Like I'm trying to run at the moment, but it won't let me. I can only walk very slowly when I'm in this mode, but it's very accurate. You can see I get hardly any crosshair shake. So very good for headshots. Now, if I pick up a melee weapon, such as the crossbar, you can see that that has its own set of animations and sounds. And you can see that when I walk, it bobs about a bit, but then when I run, it's kind of pulled in towards me, so it really does look like I'm running with the melee weapon. All melee weapons use the same animations. You'll also notice, this is a slight detour, but you'll also notice that in previous versions of this project, when we used to go up to tables and swap, let's say, the crowbar for the pistol, what used to happen is we'd very often get the weapon embedded in the collider of the table. I fixed that now. You see, all of my props were using non-convex mesh colliders. And basically, PhysX is just really crappy at dealing with embedded objects in non-convex mesh colliders. So for the most part, I was able to fix this completely by just editing the collider. If I select a table, let me select that table over there, and you can see that I've just click that little tick box that says convex. You see, when it was a convex collider, the collider very closely modeled the complex shape of the table, and that's why it was really hopeless at unembedding geometry. And we often used to embed weapons into it because technically when we drop a weapon, we're kind of thrusting it out in front of us. So when it's put into the scene, if we're stood in front of a table, it actually starts its life embedded in the table's collider. And when it was a non-convex mesh collider, Unity was not very good at unembedding that. But make that convex, and you can see it no longer tightly hugs the shape, but the collider is now a much more simple collision primitive that Unity can very easily resolve embedded geometry with. Now, there were a few cases where I wasn't able to just fix the problem that simply. One of them is across the hall in the MRI scanner room. We have this MRI scanner here, and you'll notice that this originally had a mesh collider on it. It's a very complex shape, especially with the hole cut out of this control area here. Now, obviously, if I had made that convex, what we would have had is just like a big convex collider that was nothing like the shape of the actual scanner. So what I did in that case was I actually removed the mesh collider completely. If I go into the prefab editor, you'll notice that what I've done is, after I deleted the mesh collider, I created a few box colliders and bound the separate parts of this separately. So you can see I used one box collider for the main control area, I used box colliders for both of the handrails, box collider for the main bed section and stand, and another box collider for the pillow. And once again, because these are primitive colliders, PhysX is very good at unembedding geometry with them, and you won't have a problem that we were having in the past where if you dropped a gun onto the CT scanner, it would be embedded inside the bed. That no longer happens. Okay, let's press play, go back to the weapons system again, and carry on from where we were. So let's call up the flashlight again, and let's see what happens now when I pick up a two-handed weapon, such as our shotgun. Now, our shotgun needs both of our hands, including the one that's holding the flashlight. So our arm system is intelligent enough to know that when we want to switch to the shotgun, it needs to lower the torch first. There you go. And you can see the shotgun has its own crosshair as well, and its own reload animations. I actually have no ammunition for that, so let's pick up that box of shotgun shells and let's see what the shotgun reload looks like. Shotgun takes 6 shells, but it's a very cool animator controller that we use for the shotgun, because you'll notice that if I fire 2 bullets out of the shotgun and then choose to reload again, it knows to do only 2 repeats of that reload to reload 2 bullets in the gun. Okay, so now let's go over to the assault rifle. Let me pick up the assault rifle clips first of all. Now, the assault rifle is also a two-handed weapon, but it also has a flashlight mounted on it. And because I haven't technically turned the flashlight off yet, our arm system knows that if a flashlight is available, I do still want to use it. So for example, if I switch back over to my single-handed weapon by pressing the 1 key, it will lower the shotgun. It will also remember that I did want the flashlight up, and it will bring the flashlight up as well. Now, when I pick up the assault rifle, which has a flashlight on it, of course it has to lower the flashlight, but when it brings the gun up, it will know to turn the flashlight on the gun on automatically. Hey, how cool is that? And the flashlight on the gun is controlled using the same key as we do the regular flashlight. So once again, it has its own crosshair, its own animations, and 2 modes of fire. Let me reload it a minute because it has no weapon, it has no ammunition in it. There you go. And if I zoom in, I get very accurate shots, but I can only move very, very slowly. And there's some pretty cool things with the weapon system as well, such as it automatically slows the animation down as your stamina depletes. Now, another thing that you'll notice if you start poking around our FPS controller is there have been some significant changes to it. What we actually have now is we use 2 cameras. We use one camera to render the scene, but we use another camera to render the weapons on top of the scene, because my assault rifle is some distance in front of me right now, and I don't want to put a collider on it, or otherwise I won't be able to get very close to walls and things like that. So what FPS shooters generally do is they perform a little bit of a trick, whereas they render the scene with one camera, then they clear the depth buffer, and then they render the weapon into another camera, and then composite that on top of the scene, so none of the scene ever overwrites the weapon. So this allows me, however close I get to a wall, to always draw my weapon on top of it, which is a trick that all FPS shooters do. And it means that really from a game perspective, the weapon isn't really there, it doesn't have a collider on it, we're just drawing it as an effect. Sometimes, and you'll notice this in a lot of FPS shooters, you can at times see some really extreme sort of scaling artifacts from this. So you can see if I walk up to the door handle, probably at this point in time, in reality my gun is actually poking through the door and is on the other side of the door, but because I'm drawing it on top, you can see that I can get right up to that door handle, and that can kind of make the gun look quite small compared to the door handle, or vice versa. But this is pretty much something that FPS shooters have been doing since the dawn of time, and it's just something that we all put up with, and we don't have to worry about our gun ever getting embedded in geometry or things like that. Okay, so let's talk a little bit about where you need to go to see how the weapon system works. So let's look at the FPS Arms asset first of all. So we're going to drill down into the Dead Earth folder, into the models folder. You'll see there's a folder in there called FPS Arms System, and there you can see that flashlight cookie that we're using on our flashlight, and a file in there, an FBX file called FPS Arms. Now if I select this, you'll notice that this contains not only the model of the arms, but it also contains all of the weapons that are used by the arms. These weapons are actually skinned to the rig, so that when reload animations and things like that play for, say, an assault rifle, you know, the assault rifle magazine has a bone in it, so that the animator was able to animate that bone to make the magazine come out of the gun and things like that. So all of the weapons are always in the arms at all times, and we just enable and disable the ones that we wish to show or hide at any given time. You'll also notice that this FBX file contains all of the animations for all of the weapons, and a lot of these weapon animations also have curves on them. So if I select things such as, I don't know, like flashlight rays, maybe, is it that one, and open up the curves, you'll see that that has a curve on it called left hand occupied, which tells the rest of the system that, you know, if we want to transition into a sub-state machine of the shotgun, we can't do that yet because the left hand is occupied. So our torch state machine will know that we want to change to a two-handed weapon, and it will eventually transition out of its state machine, and then none of the torch animations will be playing. Left hand occupied will no longer be set to 1, and then the transition can then take place in the animator into the shotgun sub-state machine. So all of the animations and the models for our arms system are there. And you'll also notice now in our scene hierarchy that our FBS controller has evolved a little bit. We now have the arms rig as a child of it, as well as all of these various bones for animating the weapons. And you'll notice that although we still have the main scene camera where we had it before on our FPS camera game object, this is now set to only render the scene. And you'll notice that there's a few new layers in here, but one of them is the FPS arms system. Now, the only thing on the FPS arms system layer is the arms model itself and the weapons. So this camera here that renders the scene has a culling mask on it, and it doesn't render the FPS arms system. However, if we drill down into the FPS arms hierarchy, into the arms rig, you'll see that the animator, when animating this rig, also created a bone that we can use as a reference to mount the second camera on it. This is the camera that is going to render just the arm system. And you'll notice that this camera has a culling mask on it that only renders the arm system, and it's got its clear flag set to depth only. It's also been assigned a camera depth such that it renders on top of the scene camera. Okay, so the scene camera renders all of the scene, then after all of the scene has been rendered, this camera renders on top of it, but before it does, it clears the depth buffer, so when our arms are rendering, it doesn't think anything else has ever been drawn before. So the arms always get rendered, they never get obscured by anything. In other words, they overdraw everything that's currently there. And we've had to move scripts such as our camera blood effect from the original scene camera onto the arms camera, because obviously we want that effect not to be appearing behind the arms. It's supposed to be like the lens of the camera, so we want that to appear on top of everything, the scene camera and the arms camera. Now, of course, the character manager is where a lot of this stuff is going to take place, but there's surprisingly little code for our FPS arm system because most of it is handled by the animator and curves on the animations. So if you drill down into the Dead Earth folder and into the animator controllers folder, you'll see we now have a controller called FPS arms, which is what you're looking at on the screen. It has two layers. It has a base layer that has all of the sub-state machines for each weapon, and it has the flashlight layer, which is what controls the left arm. And you can see that the flashlight layer by default, when it's not active, is just in an empty state, so it's not doing anything. But then when we transition into raising the flashlight, you can see that it checks several parameters in the animator. One of them is that, we're not holding a dual-handed weapon. If we're holding a dual-handed weapon, then the left hand isn't available, so we can't raise the flashlight. And also it checks that we're not in the middle of a reload, because of all of our weapons need two hands for reloading as well. And you'll see this works very much the same on the base layer as well. So when we don't have any weapon active, you'll notice that we just have this empty state. But then let's say, for example, we want to bring up the shotgun, which is a two-handed weapon. You'll notice that the transition into the shotgun sub-state machine checks that the left hand occupied is less than 0.25. In other words, we're just checking it's not 1. Okay, because if it is, then it means that the flashlight is probably active and we can't do anything yet. We can't transition into the shotgun yet until the flashlight has lowered itself on the flashlight layer. As soon as the flashlight has lowered itself, left hand occupied will be set to 0, and then this transition will be allowed to happen. And you can see that each of the weapons has its own sub-state machine which branches off of this empty state. So if I open up the shotgun, you can see there's the shotgun sub-state machine, there's the fists sub-state machine, there's the melee weapon. The same state machine is used for every melee weapon. There's the pistol sub-state machine, and there's the assault rifle sub-state machine. It all looks pretty complicated, and I'm not going to lie, it is. And I'm going to cover all of this in the videos. Now, for those of you that are feeling really impatient, I really am not going to be able to answer questions about this project on the forum, right? There's just too much there. This is for those of you that are really comfortable digging into the code by yourselves and experimenting. But don't worry, as soon as I get this project to you, my next order of business is going to start cranking out the videos covering this ARMS system. Okay, so that's basically the ARMS system. I suppose we better see it actually doing some damage to a zombie, hadn't we? So let's go and see our gun killing a zombie. There he is. So, oh, I need to reload it. Let's do a zoom in shot here. There we go, and oop. And then let's do a nice headshot to take him. Boof, boof, boof. He's a goner. Oh yes, he is. So you can see everything works. In fact, you can even punch a zombie if you want. There's something quite refreshing about punching zombies. Cool. So let's talk about the AI. There's been some significant additions to the AI. One of the simple ones that I discovered when I put a zombie in this level was that zombies were just a bit too stupid. Now, remember that our AI state machine has this whole kind of sensor and field of view logic that basically says, if the player is within my field of view, then I pursue it. However, what happens in geometry like this, where there's lots of tight corners, is the zombie can basically appear very stupid. stupid, right? So it could be chasing you down a corridor, and then you go like left and left again, and then like the zombie has lost line of sight of you, so it just goes to where it last saw you. In real life, it would probably be clever enough to know that if it got to that corner, that you obviously went round the next corner as well, and it would try and use some type of, I don't know, extrapolation to guess where you would be now. Now obviously we can't add that very simply, but what we did is something just as good, which is based on the intelligence of the zombie. When the zombie first sees the player, for a number of seconds afterwards, basically line of sight testing is disabled. In other words, when the zombie first sees you, for a short period of time, based on its intelligence factor, it can see through walls. So you can't simply shake off a zombie by simply dipping behind a corner and think, he can't see me now, he's just going to sit there scratching his head. Oh no, the zombie will see you for some period of time, and it works really, really well. In reality, it makes the zombies seem much more intelligent, and it makes them seem like they've figured out that you went around that corner and carried on going for some time. And we have control over this via the zombie's intelligence slider. Okay, so the next big thing is the door system. Our zombies now have the ability to open doors. We actually have 3 types of door now that is supported from an AI perspective. If I actually select one of my interactive doors, it has this new property called AI and navigation, and here we can give it one of 3 options. We can set it to be a door that the AI can open, we can set it to be a door that the AI can't open, but the AI doesn't know that until it tries it, and then we can have a door such that when it's closed it literally carves out of the nav mesh, which means a zombie literally won't even try and go anywhere near that door because it just won't be able to path over it. Now there's use cases for all of these. In the most cases, I think you're going to be using one of the top 2, which is doors that they can open or doors that they can open, but we want them to give the illusion that they at least try and open them. Whereas when a door is set to carved when closed, let's say a zombie is chasing you and it's down the end of the corridor, the minute it sees you go into that door and close that door, that path will be carved out of the nav mesh and the zombie will be forced to repath itself, and it won't even try and come and find you in that room anymore, unless there was another entryway into that room. But that door is essentially invisible to it from that point. The actual child door constructs of our interactive door constructs now have nav mesh obstacles on them that are enabled only when the door is opened or being opened. And the reason why the nav mesh obstacles aren't activated when the door is closed is because I found out the hard way that Unity's nav mesh agent really doesn't like being told to walk up to an object that is a nav mesh obstacle. You're trying to get it to go up to the door to activate the handle, but the navigation system is constantly trying to push the zombie away from the door and trying to get it to avoid the door. And what happens is you get very strange behavior. So what actually happens is we got this new script that we add to our zombies. Let me select AI Jill's AI entity game object, and you'll see it down the bottom. It's called IK Door Processor. And if I press play now, if you look in the scene view, you'll see that at the feet of the zombie, when it's walking, there's this little kind of ray. Well, it's not a ray, it's actually several line segments that are being cast along the nav mesh so that it can essentially feel ahead of time whether there is a door that is approaching. This is quite important. We can't just do a straight ray cast here because you might be coming to the door from a very tight angle or around a corner. You might be running very quickly, and we need, in the case where you're running very quickly, we need the zombie to slow to a walk before it gets to the door. Otherwise it can just very easily pass straight through the door. So we need to be responsible for stopping the zombie stepping through the door itself. And you can see as the zombie kind of walks up to the door, which is that little white line, it's now in door activation mode. It'll walk up to the door, it'll grab the door handle, you'll see its head is now looking down at the door, and then it opens the door and elegantly its hand moves back down to its side. You'll also notice that if the zombie is set to be a running zombie, then that same IK door processor script will make sure that it slows down to a walk before it gets to the door. So let me just demonstrate that for you. If I set zombie Jill's patrol state to be a speed of 2, which is jog instead of 1, and press play, you'll see she comes running in and then she slows down. There she is, and then she slows down as she gets to the door and then opens it up. Pretty cool stuff. It's really cool now because we can just leave zombie Jill to walk around the hospital and she's like opening up all the doors and stuff. There you go, here she is. Oops, she's found another door. Yeah, let's open that one. cool stuff. You can also see there's a lot going on with the door system now. For example, if I select the navigation tab, you can see that when the door is open, it literally carves itself out of the nav mesh so that the zombie doesn't try and walk straight through the door. And you can see that once the door auto closes, which will probably take some time, you can see it's uncarved again. While it's closing, it's just a nav obstacle, a non-carving nav obstacle. So if the zombie were to get caught in the door, the nav obstacle would push it out of the way, either into or out of the room, which is what we want. But when the door is opened, it's turned to a carving nav obstacle, so that it actually carves it out of the nav mesh. We now have a zombie that opens doors and uses IK on the hands to correctly open the doors. And one of the things that you'll notice as well is that it correctly uses the right or left hand depending on which side of it the door handle is on. Okay, so finally we need to talk about the IK system for going up and down stairs. Okay, so putting some step processing for the AI in this game, I'm not going to lie, was much more difficult than I expected it to be. I now understand why there's even today a plethora of AAA games where the AI bots don't handle stairs very elegantly. So first of all, let's see what happens if I bake the nav mesh just using the geometry like we normally do. So we're going to rely on Unity's nav mesh agent to traverse the stairs for us, and if I enable the height mesh, you can see that there is a nav platform, if you like, on every step. And of course, what happens is the nav agent just sees these as steps that it kind of teleports onto. So let's have a look what it looks like if we take no special action. And I'm sure you'll agree, it looks pretty ropey. Don't worry about why the zombie isn't attacking me. I've temporarily made the player invisible to the zombie, so he doesn't know I'm here. Okay, look at this. Wow, it's horrible, isn't it? It literally teleports from one step to the next. Very jerky. Quite a bit of embedded feet in the geometry as well. And of course, coming down is much the same story. So it just jerks from one step to the next. Okay, it's not the end of the world when you're playing the game, but it's not something I am very happy with at all. Okay, so one of the things that we've seen happen quite a lot in games is they often create an invisible ramp that is used for the baking of the nav mesh, and the actual steps themselves are not included in the nav mesh bake. So you'll see that I did this. So let me choose main static, which is the game object that contains the steps. Let's make these navigation not static so that we don't bake a nav mesh for it. And instead you'll see what I've done in my scene hierarchy is I have this game object called nav mesh colliders, and when I enable that, you can see we have some ramps. Now I can actually turn off the stairs for a moment so you can see exactly what it is I've created. This is the thing we're going to bake the nav mesh out of. So, oh, by the way, before I go on, let me just point something out to you here, because we are actually going to be using these ramps along with another method to get the end result of our step system. But you'll notice that if you select any one of these ramp game objects, which are basically wherever there's a flight of steps in this level, and go to the navigation menu and choose the object tab, you'll notice I've created a new navigation area called no crawling. And when I bake this, you'll see it should be a slightly different color. Should go green, I think. Yeah, you can just about see the green there. This is a special area that crawling zombies will not be able to walk on. I did mess around with trying to get crawling zombies to crawl up steps, but I just couldn't get something that looked satisfactory. So what I decided to do in the end is say that if you damage a zombie to the point where all it can do is crawl, then if you run up a flight of steps, it will just follow you to the bottom of the steps, and then it will just give up and crawl off on its waypoint route. It just looked rubbish having them crawling up the steps. I had all sorts of embedded geometry, because obviously the crawling animations are horizontal, so even if I rotated the nav agent so that it took on the angle of the slope itself, when you were at the bottom of the slope and you first rotated it round, the legs would completely disappear into the floor, and it looked rubbish. And I did experiment with, well, what if when it hits the ramp I make the bottom half of the body a rag doll, so you know it's just kind of dragging the legs behind it. That would automatically solve the collision issue, but that's not easy either, because because when you have an animator on a game object that's enabled, it overrides any physics anyway. It takes total control of the bones. So that didn't work. So in order to do that, you literally have to create like another object of just the legs and kind of tether it to the zombie game object and somehow make its other legs invisible. And that was just not something that I thought was going to work out very well. Okay, so what I've done now is I have created a ramp. So let's just check that our zombie can walk up that ramp. Now obviously that's a lot smoother. It looks a bit silly because we haven't got any steps in place, but at least if you're at the top of the stairs and this thing's coming at you, it's not going to be kind of bopping about like it was before. Doesn't look too bad, but of course the legs look awful. So what we can do is turn off the ramps again, because we only wanted those ramps for the baking of the nav mesh. I'm going to turn those off now in the hierarchy, and then I'm going to re-enable that game object called main static, which is what contains the steps. So the steps are there visually, but our nav mesh agent knows nothing about them. So we can see the steps, and our FPS controller will walk up the steps, but our zombie will just walk up the ramp. And as you can imagine, this is actually what a lot of games do, even today, and they just put up with the feet kind of embedded into the geometry. But it's only an aesthetic problem. The zombie knows nothing about the steps, so it's just walking up the ramp. You can see this does, the walking doesn't look anything like the sort of walking you'd be doing if you were walking up steps in real life. Let me just say, first of all, that, if I had a professional software house at my disposal, what I would probably do is, first of all, lay down some very strict rules to the level artist and say that make sure that every step is exactly the same dimension as one another. You can already see with our steps that that's not the case, right? You can see that this bottom step here is only a half tile high, whereas some of the other steps in the same flight are a whole tile, or 3/4 of a tile, and then some of the other steps in the level are whole tiles, so they're even bigger than these middle steps here. So we don't even have a uniform sort of step height that we're dealing with. But assuming that we did, what we would probably do then is then tell our animator to make a very custom set of walking up and down step animations that we can use. But even then, it's not that easy to make sure that we get the zombie in the exact right place to start playing that animation without having to kind of snap the zombie to a very specific point at the bottom of the steps, and then maybe rewind the animation to the exact point in the animation where it needs to start stepping forward. This creates both a positional glitch as you see the zombie snap into its position. You also get an animation glitch if you do need to spool through the animation to maybe the point where you wish the walking to start, because you never know at what point in its walking stride it's going to be when it reaches the bottom of the steps. So I found that kind of glitch was more of an eyesore than the system that I eventually ended up creating, which is an IK system which doesn't get it right all the time, okay? But most of the time it gets it right, and it looks pretty good when it does. So my system is to use the ramps like we have here. So as far as our nav mesh agent is concerned, these steps don't exist at all. It's just walking up a ramp. So we get that nice smooth walk up the steps. But while we're walking up the steps, we're raycasting down from the zombie's feet, and we're performing IK on the feet so that they can snap to the steps. Now that's it in its most basic case. I've actually got 3 different flavors. Now if you look here, you can see the final solution that I developed. Here's the zombie walking up some steps. I'm sure you'll agree that looks a lot better than any of the 2 methods that we've looked at so far. And here it is walking down some steps as well. And I'm pretty happy with this. Like I said, sometimes it gets it wrong. And when I say it gets it wrong, it just means that it might look a little unnatural sometimes. There may be times when, depending on whether it started these steps with its stride slightly off, there might be a case where maybe he stretches over 2 steps every now and then, or perhaps he does a climb and both of his feet land up on the same step. But more often than not, it walks the stairs fine. And in cases where it doesn't, it kind of corrects itself very quickly. And in the game, when you're running away from this zombie, you're just not going to see it. So let's talk a little bit about how this system works, or at least where the components are in the project. There are basically 3 components, if you like, to our zombie step system. Now the first one is that for every animation that we wish to use when walking up steps, we have to create a scriptable object for it. And you can see that I've created mine in the Dead Earth folder, in the animations folder, and you'll see there's now a folder in there called procedural IK foot system data. Now it might look like the these scriptable objects have lots of funny names, but these are actually the names that match the animations that are being used in Zombie Jill's controller. Now at the moment I've only done this for Zombie Jill, so if you put any other zombies in the level, they're not set up correctly with all of this stuff. So what I basically did was I opened up Zombie Jill's animator, right? And you can see on the base layer, for example, if I select the zombie walk state, you can see that is using an animation called 132_46. And we also have a scriptable object that matches that data called walking 132_46. If I choose zombie jog, you can see that animation is called zombie_run. So I've called the matching scriptable object that goes with it zombie run as well. And it is a bit tricky setting up this data. You can see we've got different settings for going downstairs and upstairs. There's actually 3 different types of IK that we can perform, and I'll talk a little bit about how they're used in a moment. But the most advanced one is animated arcs, which not only snaps the feet to the steps as you're walking up them, but also basically creates arcs as you step from one step to the other. So rather than seeing the feet snap from one step to the other, they literally raise up in a much more natural looking manner. So this data basically tells us things such as how far the foot bone is off of the floor, and that's very important because the foot bone with respect to Unity's feet IK is actually the ankle bone, so it's not normally at the very bottom of the feet. So you can see here I've roughly calculated that the ankle bone is about 0.175 meters from the base of the foot. So I need to make sure when I place the feet on the steps I sort of offset them by this much upwards, otherwise the base of the foot would actually be embedded into the floor and it's actually the ankle bone that would be on the floor. We also have the ray origin height and the ray cast length. This is basically just allows us to control where we start the ray casting from above the foot. 0.75 is from round about the waist height, and how far we cast down. I just cast down 2 meters, which is more than enough. And then I also have this setting called IK to animated cooldown speed, which I've set to 4 seconds. What my system actually does is it kind of creates the feet animation on the fly using the original animation as a base. But what we do when we're walking up the steps is we restrict the stride, because normally if you're walking on the flat you're taking big strides. Now if we were just to leave those strides as they are, what we would see is when we walk up the steps, a single stride would span 3 steps. It looks kind of weird. So we want to be able to reduce the stride length, and you can see we actually have a setting here for that, which is stride size. And we can also reduce the stride width as well. If it's a running animation, for example, you could make the feet go wider or more narrow as they go up the steps. And we also have the speed scale. The speed scale is how much the base animation will be slowed down when it goes up the steps. You can see in this particular case I've slowed it down to 0.65 of its original speed when it goes up the steps, or otherwise it will walk up the steps far too quickly and it will start spanning multiple steps at the same time. The way that this system works is our animations, all of the animations for which we've created one of these procedural IK step system scriptable objects for, also have curves added to them. Yes, those dreaded curves again. And we actually have quite a few of them. You can see I've got the left stride and the right stride, which basically just will tell our procedural IK foot player, which you'll see in a moment is a component that we're going to add to Zombie Jill, when exactly the foot is out in front and when it's behind. So you can see that more often than not the left and right foots are exact mirrors of each other. So you can see at this point where we hit 1 in the curve, this is where the left foot is right out in front of the zombie. The same too for the right stride as well. And then we have the left foot planted and the right foot planted curves, which tell us where exactly when walking up the steps do we want the foot not to be free moving but to lock on to the step. And you can see in the case of the left foot, this is usually when it's just in front of the player and about to be put onto the ground. That's when we're going to lock it into position on the step and keep it there until we release it again, so we don't get foot sliding on the steps. And then finally, if we're using the most advanced form of the IK, we can use these left foot arc and right foot arc curves, which means that for the foot that isn't currently planted, rather than just stay there and be snapped up to the next step, it will perform a nice smooth arc up into the air and forward. And that's what these curves basically do. And they're usually just in the 0 to 1 range, or in the case of the stride in the -1 to +1 range. -1 being when the foot is right behind the player, +1 being when the foot is right in front of the player. Our animation has to have these curves set up for it, and then it has to have one of those scriptable objects that we just talked about, describing how the speed of the zombie is going to be slowed down, how the stride of the zombie is going to be altered to a fraction of its normal walking or running stride. And then what we do on the actual animation itself is we add an IK procedural step system state machine behavior script, Just like we do with all of our other scripts, we also add one of those layer exclusion string lists to it, so it knows not to process it if, for example, it's a base layer animation and the lower body layer is overriding it. So we created those string lists, if you remember, ages ago when we were working on our zombie sound system. We're just reusing them here. And we also assign it the scriptable object that contains all of that data so that it knows exactly how the animation should be altered. Now really all this state machine behavior is doing for the most part is at runtime, it's just sending this scriptable object to Zombie Jill's AI entity, which now has on it a new script called the IK procedural step system player. So as we go from one animation to the next, this step system player is being provided with, by means of the state machine behavior, the exact scriptable object that contains the animation data that it needs to create the procedural animations that will make it walk up the steps. The actual player itself on Zombie Jill has a few settings. We just need to tell it what the step layer is. Now we'll talk about that in a moment. And also whether we wish to scale the data in that scriptable object, because it's all very well setting the stride width and the stride length and the scale speed and things like that. But of course, we might be using the same animations with zombies that are scaled to all different sizes. So we can actually scale the data in that scriptable object as we're applying it to the zombie's footsteps, so that a bigger zombie would take bigger strides and would walk more quickly up the steps. So the only thing that we haven't really talked about is the steps layer. This is the missing piece, and you'll see that what I've had to do is I've created separate colliders for each of my stairwells, which is a bit of a pain in the ass. I won't tell a lie. So let me enable those, because they need to be enabled at runtime now. And you can see that for each of my flight of steps, I've created a collider on each step, which is assigned to the step layer. Now in fairness, if the steps had been a separate model, I could have used a collider on those steps and I wouldn't have had to have created these separate colliders. But when I was given this model by the modeler, these steps are embedded with a load of other geometry as part of the same mesh. So I had to individually create all of the steps colliders for all of the flights of steps. They're just boxes and they're just set to the steps layer and they're colliders. I originally created them by just adding cubes into the scene, and then I turned off the mesh renderers. I may have the mesh renderers still on there. If I open up staircase 1, go to say the second step. But yeah, you can see the cube is still there, but I've just turned off the mesh renderers. I like adding cubes instead of just the colliders because it's much easier to size them correctly to the size of the step when you've actually got the cube being rendered in the scene view, and then I just turn them off. When the zombie detects that it is over one of these colliders, it knows to activate the procedural IK step system, and from that point on, the procedural IK step system player starts basically generating the footsteps of the animation itself in the code. And that code can look a little bit complicated when you look at it, but in the videos when I cover it, you'll realize it's actually not as complicated as it might first appear. So the code for the procedural IK step system, where all the funky stuff is literally in that IK player, which is on Zombie Jill, this component here. And it's really nice because we've been able to add this functionality and the door functionality without really having to play around with the guts of our AI system. They're just components that we've been able to kind of bolt on to the game object to provide that functionality, which is really nice. So I hope you enjoy having a little play around with the project, the new weapon system, the step system, and the door system. And I will be back very shortly to start covering this stuff in our actual project from the ground up. I'm going to start with the weapon system, and then once we've got all the weapons done, we'll then start putting a zombie in the scene, and then we'll start addressing all of the issues with steps and its intelligence and all the things that I talked about earlier in the lesson. Finally, let me select one of my procedural IK step system scriptable objects and talk to you about the 3 different modes that are available for going up and down steps for any given animation. They all have their advantages and disadvantages. The most advanced one is animated arcs, but let's just start at the most basic, which is the simple mode. Now in simple mode, the animation's stride is not altered in any way at all. All we simply do is we let the zombie, or the nav agent should I say, walk up the ramp just as it normally would, but as it's walking up the ramp, we just make sure that we raycast down from the feet and snap them at all times to the height of the step that's beneath those feet. Now this gives the impression that the feet are kind of dragging along, so they kind of get dragged into a step and then popped up, but it's still a pretty good method to use for things like, let's say the zombie's walking up the steps and it goes into the alerted mode, which remember is when it kind of turns left and right on the spot. Now we don't want to do any advanced IK in that case. We just want to make sure that as it's rotating on the spot, we're making sure that its feet are always being clamped to whatever step it's just moved over. With animated mode, it's really like a cross between simple and animated arcs mode. That is that the feet are always still snapped to the height of the step that is underneath that feet. So once again, it does feel like the feet are dragging from one step to the next. They're never lifting off of the steps. But once again, this looks pretty good a lot of the time when coming down steps. And it doesn't look too bad either when going up steps, especially in an animation such as a fast run or a sprint, where you don't really see the complexities of the animated arcs mode anyway. You know, it's all a blur as the zombie's running up the steps. What animated mode does do is it does scale the speed of the animation, so it makes the zombie walk up the steps more slowly, and it also modifies the stride length and width as well, so the zombie takes it one step at a time. Obviously in simple mode, where we're not modifying the speed of the animation, we're just snapping it to the steps underneath it. Obviously a walking on the flat animation normally is taking much larger strides than a zombie would when it's walking up the steps. So in simple mode, you'll see the zombie literally skip 2 or 3 steps at a time, whereas with animated mode it won't do that, but we also won't get the feet ever kind of lifting off the steps. But when we use animated arcs mode, that's when those additional curves come into being, the plant curves in the animation. When the plant curve is 1, the foot is actually snapped to the step, but when it's not 1, the arc curve is used to make the foot kind of raise off the ground gracefully and make it kind of transition smoothly up to the next step. You'll also notice that this is a custom inspector with a snazzy little logo for this little tool, and I'm going to cover in the videos how I did that as well. And you'll notice that, like, if I go to simple mode for the down settings, then a lot of the parameters that are no longer applicable to simple mode are just no longer shown in the inspector. That's the beauty of custom editors. So that's pretty much it for now. There's been lots of changes to the character manager to integrate the arm system with the inventory. And there's also been some changes to the character manager and the FPS controller to get data to and from the animator for the arms as well. So for example, I think I touched on this earlier, you know, if you run out of stamina, you start to see the animation slow down and eventually transition to another type of animation for the arms. So clearly we need a way to take that stamina and feed that in as a parameter to the arms animator, and also the other way around. For example, if we're running and we've got lots of stamina but we decide to zoom the weapon into that dual mode I was talking about, well then the animator then tells our FPS controller, look, I don't care how much stamina you've got, you need to slow the hell down because we're now in kind of sniper mode, for lack of a better word. Okay, so thanks for listening guys. I hope you enjoyed this project, and I will be back in short order with the next video in this series where we're going to start building all of this stuff from scratch in our Dead Earth project. Bye bye now.